Okay, I'm going to test out my new comparator board, revision B, that has the order corrected. So I've just powdered it up, so now we have 0 in the two registers. This is the A register, this is the B register. So right now we have 2 lights on. Those 2 lights, the 4 lights actually are written here on the board. So A greater than B, A equal to B, B, A less than B, and then 0. So we have 2 LEDs on. We have the A equals B, they're both 0, and then we have the 0 flag, which is the B register is 0. So that all works. So let's put something in one of the registers. Let's put the number 1 in one of the registers. So here we have 1. I'll clock that into a register. So I've clocked it into the B register, so our 0 has gone off. And now we have the A is greater than B. Is that right? A is greater than B. I guess these are backwards. A should be this one. Maybe I just have the labels backwards. So let's assume this one is B greater than A. Got to be one of the others. So anyway, this is greater than or less than. Let's try the equal one. We'll clock 1 into the other. Now they're both equal, so the equal light came on. That's good. Now let's put 0 in here. So the other light, the 0 light came on because this is 0, and then the A less than B. Yeah, so my labeling is wrong. I'll just have to remember that. The silk screen is wrong. I just change the wires around. Anyway, so this board works fine. So let's glad that one works now. What I want to do is change this one out and put on our new ALU. So this is the new ALU, and it's a bit backwards than it was before. So we need to go this way now. So the long end, because the bits order changed, it was easier to lay out the other way around. And so I'm going to have to change these sockets on the motherboard to fit this. So now we'll be able to put it on and go from there. So let me work on moving this stuff around so this now we can now attach this correctly and go from there. All right, have it attached now. See on the side here we have the input switches, the bus monitor, the register B and the register A, and then the ALU goes on top. So that's good. Need to add our indicators. One here, and put one there. There we go. So we'll be able to load data into the 2 registers and then take a look at the output on the bus. And so I need to hook up these lines, which are S0, 1, and 2, for what function do we want on the ALU. And then we'll need the carry in and the write, or actually read enable, which will turn on the tri-state buffer and put things on the bus. So let's get that wired up. Alright, so loaded up. Currently I have 1, 0, and we're going to be doing an operation with S1, 2, and 3, which are these 3 switches here, if you can just see that. Just out of camera, there's 3 switches that I can set the S1, 2, and 3. So I'm going to set them all to low. So I have 0, 0, 0, and let's see, I need a carry signal. So let me find a wire for carry, which is unfortunately underneath the camera here. Here we go. All right. So carry in, I will set carry in to low. All right, there we go. All right, so 0, 0, 0 should be the clear function. So if I enable the bus, I get 0. And then 1, 1, 1 should be, what do they call it? They call it preset. So it should give us all 1s on the output. And it does, all 1s on the output. Okay, so high, low, low. Let's see, high, low, low should be, oh, we don't want to do that one. Let's see here. Let's do A or B. Let's do high, low, high. High, low, high is an OR function. High, low, high is an OR function. It's not ORing. That's interesting. Let's do the AND function. Low, high, high. Low, high, high. That looks like an OR function. Maybe I have these bits backwards. Let's see here. I have... Oh, I do have them backwards. Let's see here. I have low. Let's see here. I should have orange, brown, white. Ah, these are reversed. Okay. Orange, brown, white. Oops. There we go. Orange, brown, white. Orange, brown, white. Then go to these. There we go. That's what. Okay, so let's do the OR function, which is a high, low, low, high, low, low. There we go. There's an OR function. So we have this or this. That's correct. And we'll do an AND function, which is low, high, high. Low, high, high. And that's 0. That's correct. And let's do a plus B, which is high, high, low. High, high, low is plus. Ah, there we go. Let's do a plus. So let's load something interesting in the B register. Oops. Get rid of our bus assertion. Here we go. Okay, so now we have 7 plus 1 should give us 8. Yay! 8. Excellent. Knows how to add now. Good deal. Okay, so let's try to do a subtraction, which is trickier. Let's do a, let's see, this is A and this is B, so we'll do a B minus A. B minus A is a high, low, low. High, low, low. Okay, which is giving us a 5. Should be a 6. 7 minus 1 is 6. But whenever you do a subtraction, you have to change the carry in bit. So if we change the carry in bit, we get a 6. Excellent. So we have a working ALU. Very, very good. So we have an 8-bit working ALU. So that's like the core of the machine. So very good. So we have a working comparator, we have a working ALU, registers work fine even though they're backwards, but it doesn't matter. Our input is correct, everything is correct except the only thing that's backwards is the program counter, which I definitely need to fix. And I've decided to go ahead and relay out the RAM board as well. Even though the RAM board would work perfectly fine the way it is, it's backwards, but it doesn't really matter if what bits go where as long as they come out the same way. I really like the suggestion one viewer had on putting in a place for LEDs so you can watch the address counter. So on a lot of microprocessors you have an address bus and you have a data bus. And here on this machine we only have one bus. So we really don't know where our address is set. So if we put an internal connector here on the RAM card, and we put some LEDs, then we'll be able to view the address bus. So we can see the address bus here, we can see the data bus here. That will be a great addition. And I'll lay it out correctly so DT0 through D7 works correctly, so to reduce the confusion. So that's great. Our state machine seems to be laid out correctly, so that's good. I think there's another board that I want to make, which is a ROM board. It might complicate things a bit, but it'd be nice to have a ROM so we can actually load a program, or maybe even load a monitor program. So I think, and maybe make it a 28-pin DIP package, a lot like State Machine, so I can program that on my PROM programmer. So we can write a program offline and put it in and run the program. Otherwise, we're always trying to toggle in programs into RAM, and then they disappear when we turn it off. So I think that will be good to do. So a couple more cards, but I think it's coming along great. Everything seems to be working okay. Some label confusion on the A greater than B, B greater than A. It's funny because I know when I laid out that card, I thought, oh, those are backwards, and I flipped them around. I probably had them right the first time and then flipped them around backwards the last time, but it doesn't really matter. Just have to keep it in mind. All the bits are there. Yeah, so far so good. The chips that I'm using here on the ALU are the F version, F as in Frank, version of the chips. If you take a look online to try to find a 748081, a 381 or a 74382, you'll find that you can't get them in an LS package or an HC package or whatever. They really only made, I think, in two varieties. They are made in the F package and the S. So the F as in Frank and S as in Sam are fast versions of TTL. F stands for fast and S stands for, I forget what the S stands for, Shocky, or I don't know. S stands for speedy, maybe. Anyway, if you look around, you'll find those. So this board worked out very easily using the 74F382 in both spots. It uses a ripple carry from one 4-bit ALU to the next 4-bit ALU, which is slow. But hey, this thing's never going to be fast, so I'm sure it's plenty fast enough. You can put combinations of 381s and 382s together and use a carry look ahead to speed things up, and then it requires, I think, a 183 chip to help everything along, so it just gets complicated. So I think this is the easy way to do it, and I'm going to stick with that. I found a source for some F versions, so that's good. Yeah, we'll go from there. One of the things I had to do is to, I had these pins on the RAM, the registers, and I had to bend those at 90 degrees to get the, otherwise this board was in the way, so I just bent these to 90 degrees and put the wires in sideways. But yeah, so now we're adding, we're subtracting, we'll do everything the ALU can do now, and yeah, that's great.